Good afternoon and welcome to the screencast. Finally, a full day of school edition. Welcome back, especially those of you in the Northeast of America know how extraordinarily cold it's been. It's so nice to be getting warmed up today with a healthy dose of mathematics. And today we're going to be talking about algebra and very similar. Should feel very much like a pattern, very similar to addition and subtraction. Today we're going to do multiplication, and we're going to use very essential concepts to solve multiplication problems, and specifically using our division property of equality. Let's take a look at an example and get started right away. That's enough introduction. If I have a math equation, 2, and we discussed in class today, when I put a constant 2 next to a variable x, that really says 2 times x. And we do that for many different reasons in algebra, one of them being, well, we don't want to write x's that look like multiplication symbols and vice versa, or it could get confusing. So we're just going to know that when we see this 2 next to this x, that is saying 2 times x. And we also know that it's going to equal 10. Most of us know that. Even some of our parents know this simply by looking at 2 times what number is 10. But let's prove it mathematically. We're going to use that division property of equality to figure this out. I'm going to divide both sides by 2. And if you ask me why am I divided by 2? Well, because the variable is on this side and the constant 2's are here. I want to get rid of that 2. The opposite of multiplication is division. 2 divided by 2 is 1x. So I'll just draw 1x. I hope. There it is. Equals 10 divided by 2 is 5. And if I go back to my original problem and plug a 5 into that x, it would say 2 times 5 is 10. That makes sense to me. How about another one? Very simple also, but let's just make sure we understand the concept. We have 3 times x equals 6, and we're trying to solve for x. Since this is multiplication, what am I going to do first? That's right, division comes first. We divide both sides by 3. I'm dividing by 3 because the constant 3 is over here on that side of the equation. Some of us have been using this line to separate both sides. Notice in my first example, I did it and it worked out fine. 3 divided by 3, well, that is 1. 1 what? 1x. And that equals 2. How about a word problem? Asante and his friends shared a cost of a package of blank CDs. The package cost $24 and each person contributed $6. How many people shared the cost of the CDs? We're writing multiplication problems. Even though this feels a lot like a division problem, yeah, I agree. We're just kind of like reverse engineering. Because technical term we do. I see numbers. I see a 6 here, $6. The 24 there, and it seems like that's going to be the total cost of all the CDs, and this is just part of it. And I'm not sure how many people, so maybe the how many people will be my variable. Okay, so if I wrote 6 times the number of people, not sure yet, that's going to equal 24. Let's use my division property of equality. We're going to divide both sides by, think about it for a second. Right, we're dividing by 6 because 6 is on the variable side of the equation, if I'm looking at both sides this way, and we want to isolate the variable. Get it to be all by itself. 6 divided by 6 leaves me with 1x. There's my 1x. That equals 24 divided by 6, which is 4. Let me put my math brain on very quickly. If 4 people put together $6, do I have $24 for the cost of CD? I sure do. There you go, ladies and gentlemen. That's how to use our division property of equality to solve multiplication equations. Ladies and gentlemen, have a great night, stay warm, and that is the maths you should know.